Now that you've done some significant work with arithmetic sums and geometric sums, we're going to start talking about their closed formulas. So in this first video here, we're going to look at finding a closed formula for an arithmetic sum. We're going to do an example first just so you can see the techniques at work, and then we're going to find the general formula. So the example that we're going to look at for an arithmetic sequence is just, we're going to start with 4 and add 3 to get the next term. So the sequence that we start off with is 4, 7, 10, and 13. And the sum we're looking at is we're just going to find the sum all the way up to a sub 8, which is the first 9 terms of the sequence. Because remember, our sequence starts at a0. So note that a0 is equal to 4, that's our first one, and so we go from a0 all the way up to a9. So we can write that same sum if we want to, and it turns out to be convenient to do it this way by writing the same terms in the opposite order and adding them up, same number, because we can add in any order and get the same result. And if we line up the terms, here's what happens. And what we're going to do is we're going to add up everything on the left-hand side, and we're going to carefully add up stuff on the right-hand side. So on the left-hand side is easy. We had S8 plus S8, and that's just 2S8. Now when we add on the right-hand side, we're not going to just add them linearly horizontally, right? Because that will be very difficult. But if we add vertically on the right-hand side, that's actually going to be rather nice, because we get 28 plus 4 is 32, 25 plus 7 also 32, 22 plus 10, also 32. All those terms that we add vertically are going to be 32, right? So when we add the numbers that are above and below each other, we get a bunch of 32s. How many 32s? Well, we get 9 of them, which means that when we get 2 times S8, which is what we get from adding the left-hand side of those equations, that is going to be equal to the sum of all those 32s. Now, this is one way of writing 32 added to itself 9 times. And here's another way of adding 32 to itself 9 times 32. So we get 2 times S8 equals 9 times 32. If we now divide both sides by 2, we get a nice formula for S8. 9 times 32 over 2, which equals whatever. I'll let you do the rest of the arithmetic. We've done the hard part up to here. Now we're going to see what it looks like in general, and it's going to be the exact same thinking as before, but the terms are going to be a little more messy because we're looking at the most general way we can think about arithmetic sums. So here's what an arithmetic sequence looks like in general, right? We start with a, that's our a0, and each time we go to the next term, we keep adding r. So a plus r, a plus 2r, a plus 3r, etc. Right, you can already see that the terms themselves are going to be algebraically a little more messy. So if we want to find Sn, we start with a0, that's our a, and we add up all the terms until we get to a plus nr. And I left some weird spacing in there because, remember, we're going to have to line stuff up eventually, and I want to make sure that it lines up nicely. But other than that, it's looking good. Now, if we add those terms in the opposite order, see, this is why I made the spaces so that they lined up. This is what we get. And the thing to notice is if you add the left-hand side, it's just like before, 2 times Sn. And if we add the right-hand sides, we're going to add that vertically. This is a little less easy to see. You're going to end up with 2a plus nr. That's going to be easy. If you look at the first and last terms, that's actually pretty easy because you just get a plus nr. That's fine. But one thing to notice is as you travel from left to right, the top gets bigger by r each time, and the bottom gets smaller by r each time. So when you add them together, those bigger by r, smaller than by r kind of cancel each other out, and you end up with the exact same number. So each vertical sum is going to be 2a plus nr. So how many copies of 2a plus nr are you going to be adding together? Well, let's see. You start at a plus 0r, that's a, and end at a plus nr. And if you look at the number of integers between 0 and n, that is going to be n plus 1. So you get n plus 1 terms. So that tells us that 2 times Sn is n plus 1, the number of terms, times that 2a plus nr. And now all we have to do is divide both sides by 2, and we get a nice formula for Sn. n plus 1 times 2a plus nr all over 2. So here, that's a nice, I mean, it's nice that we were able to get a closed formula, But here's a way that I think is more helpful to look at it when I'm actually doing problems and have to like recall what the formula is, right? For one thing, I mean, that 2a plus nr, that's not one that just sort of rolls off the tongue, especially conceptually. Where the heck did that number come from? Well, if you think about where that number came from, it came from adding things vertically. And if you think about the first time we added vertically, it was adding the very first term, that a, and the very last term, the a plus nr. So really, all I have to do is know what the first and last terms are. I can add those together. That's my 2a plus nr. What was the n plus 1? Well, that was just the number of terms in the sum, right? And then if you want to think of it in those terms, the way you can think of Sn is, how many terms do you have? You take the number of terms. You multiply that by, well, the number that you get by adding the first term and the last term. So you figure out the number of terms, you add the first term and last term, multiply those two together, and then divide by 2. All right, so now I go back and work more on those more arithmetic and geometric sums on the PDF file if you didn't get through those. If you feel free to use the formula that you have here. That might be helpful to you. And then the next video is going to be on geometric sums.